Hi everybody, David Peacock here. You know, it's interesting. Whenever I was trying to think of examples of various types of rectangular prisms or cylinders, it was very easy. I could have used, well, I did use this box of cereal, but I could have also used, say, this box of Bisquick, this box of Pop-Tart Bites, this box of Ritz crackers, as well as the boxes that are on the inside. I could have used, say, this box, which happens to be a thing used to cook eggs. I could have even used this box for the all ages edition of Charty Party. All of those are things I could have used, but it's very hard to find an example of a pyramid or a cone. I mean, the closest I can find in this entire kitchen is, for instance, maybe like this bottle of tea kind of fits that. But those are just far less common. But either way, today we're talking about volume and surface area of pyramids and cones. And this is geometry. All right, so let's talk about surface area and volume in pyramids and cones. We're going to start with surface area. So to understand surface area, we first need to understand all the sides of a pyramid. So the vertex of a pyramid is the point opposite the base of the pyramid. Now, the base of a regular pyramid is a regular polygon. And the lateral faces, in other words, the side faces, are congruent isosceles triangles. You can see these all right here. And they are triangles because they're all going up to one specific vertex. The slant height of a regular pyramid is the distance from the vertex to the midpoint of the edge of an edge of the base. So it's this. Rather than being the normal height or altitude, it is the height down the side. So like if we were on a mountain, the way that we'd actually get down. The altitude of a pyramid is the perpendicular segment from the vertex to the plane of the base. So it goes to the center, basically, of the base. The lateral faces of a regular pyramid can be arranged to cover half the rectangle with the height equal to the slant height of the pyramid. So you can see that right here. Basically, we have four equal size triangles, all of which have the base of a side times the height of L. Now, the width of the rectangle is equal to the base perimeter of the pyramid. So if we had, like, say, a 7-sided figure, there would be 7 of these triangles instead of just 4. If we had a triangular pyramid, there would only be 3. So let me explain a little bit more, another visual of exactly what what slant height is versus the normal altitude. So let's take a moment to talk about the difference between lateral height and altitude. Now, it was surprisingly difficult for me to find any sort of cone or pyramid until I found this tiny little Lego tree. So if I'm going to talking about the height, it's just the actual tallness from here, from the bottom to the top. So kind of like the middle line that you can kind of see going through. Whereas the lateral height is this distance over here on the side. It's the distance that it would take to go down, almost as though one is you went down a mountain through an elevator, and the other is that you went down a mountain, well, down a road or any other way you could actually go down a mountain. All right, so now let's look at our surface area formula. So lateral area is basically if I was only talking about the sides. So for instance, this waffle cone, there's no like base here. So it ends up being 1/2 of the perimeter times the lateral height. That's it. It's just 1/2 of the perimeter of the base times the lateral height. Now in a cone, that's the same idea. By the way, instead of a regular cone, we would call it a right cone. Now what if we actually had a base like, say, this drumstick right here? Suddenly, we have a total surface area where we also have the bottom. So for that, it ends up being 1/2 the perimeter of the base times the lateral height, but then we also have to add the area of the base. So now that we talked about surface area, let's talk about volume. The volume of a pyramid is related to the volume of a prism with the same base and height. So basically, the relationship can be verified by dividing a cube into 3 congruent square pyramids, as we can see right here. So we could create 3 square pyramids if we were to have, do this. So basically, what that ends up meaning is that we have 2 specific volume formulas. With a pyramid, it ends up being that because we can go into 3 figures instead of 2, we're going to say 1/3 the area of the base times h. Now notice we have the letter h instead of L. That's because we were talking about the actual height, like the altitude, instead of the lateral height, like the length of the side. Now with a cone, our formula ends up being 1/3 times pi r squared times height. And that is because, of course, in the case of a cone, 1/3 pi r squared times height, because that's just the area of the base. So that's really it for the formulas. That's really it for today. I want to thank you all for watching, and I ask you to please like and subscribe. I will see you again next time here on Geometry.